About open hardware. Our speaker will speak about how to build yourself a Linux computer in do-it-yourself mode, and a stuff called OLinuXino. Here is Tsvetan Usunov, and let's applause him.
Thank you. Hello. My name is Tsvetan Usunov, I am from OLinuX, and today I will speak for do-it-yourself Linux computer. Linux computer who everyone can build at home. What is OLinuX? OLinuX is my company with 22 plus years of experience with electronic design and hardware. We have about 600 different products, and half of them are open source hardware. First, I would like to make clear what is open source hardware, because many people are confused about this. When it's about what is open source software, free open source software, everybody knows what it is. But with the hardware, everybody is confused. Even my friend Leon, who had talk before me, he said Kubi board is open source hardware, which is not true. No problem. To be open source hardware, one design has to be with public CAD files. The CAD files, this is the source. This is what you can study, modify, or reproduce. If you have, for instance, just the Gerbers, you can make the boards, but you cannot change them. If you have, for instance, the schematic in PDF or JPEG format, okay, you see the schematic, but how do you change it? You can study something from it. If we make analogy like with the free open source software, to have the Gerbers and to have PDF schematic is something like to have binary blobs. You can study from them, but it will be a reverse engineering. It will be not the native study. So, if one hardware has to be named open source, it has to be unconditionally open with the CAD files. No logins, no restrictions, no registrations. The CAD files has to be present. Of course, there are some people who are orthodox and they go deeper and say, no, it's not open source hardware if every component is not open source, but it's a bit silly. For instance, what is open source resistor? Do you know the composition of the resistor or open source capacitor? Do you know what is the composition of the electrolyte in the capacitor? And why do you need this? Will you reproduce the resistor or capacitors at home? It's nonsense. So if the schematic and the CAD files are open, for me, it's enough, because you can study, you can modify, you can make your own boards based on this design. How it started? Of course, it was inspired by Raspberry Pi. Who don't know what Raspberry Pi is here? Oh, we have one. Okay. Raspberry Pi was so exposed in all the medias since 2011 that everybody was expecting this low-cost Linux computer. And us also. I still do remember in Embedded World, this is the biggest event for embedded technology, they had to start selling Raspberry Pi. And there was a crowd maybe bigger than in this room. We all was waiting in the front of Farnell booth, and they present two boards and they said, this is Raspberry Pi. You cannot order now, or if you order, you can wait 16 weeks to have it delivered. And then I asked myself, why don't make one computer who everybody can make at home? And to open source it, then there will be no supply problems, because everyone, instead to wait 16 weeks, can make it by himself. Or many manufacturers having the design can start producing it, so there will be no supply problem with this computer. And this is how the idea for do-it-yourself computer started. first, we had to select what processor to have. This one is BGA, which is used in the Raspberry Pi. You see, it's 100 of small balls with solder, and you have to connect it somehow to the PCB. On the right side, you see one guy how did this at home, but I don't think many of us can reproduce this result. So it has to be something very easy to solder, even at home. We start searching for this processor, and we found Freescale IMX233. It's in soldering-friendly package, TQFP package. Of course, it has to, you must have some skills with the soldering iron, but many people can solder this at home. So it's not like the BGA you saw on the previous slide. And we made basically few boards based on this design. The simpler one is double side. So even people can make it with, there are some geeks which make PCB at homes. They can reproduce this board by themselves if they don't want to pay and get professional printed circuit boards manufactured. But basically, this is what we did. And all these 4 types of boards are possible to solder at home. We opened the CAD files. There was hundreds of people who modified this and manufactured by themselves. For instance, there are some countries with very strict import procedures, like Brazil, for instance, or Russian, and we got a lot of feedback from people from these countries which reproduce our design, make their own designs based on it, and start producing the board. So, of course, this processor is with humble specifications. You can see only 64 megabytes of RAM, only 400 megahertz, and people start immediately comparing with Raspberry Pi. Yeah, this is open source, good, but it is too slow, not capable. And then we found OLWinner A13, which is also in TQFP package, but Cortex A8, running on 2 gigahertz, and it's about 4 times faster than ARM11, which is used in Raspberry Pi. Of course, it had its price here because the RAM for this processor is not available in TQFP package. But still, this RAM chip is with only 30 solder balls. So, not so difficult. If you are skilled, you could eventually reproduce at home. And of course, it's a trade-off. You cannot have the fastest processor, the fastest technology, and to be built at home. So it was compromise, but still computer which you can still build at home. At that time, people again start comparing with Raspberry Pi. They said, yes, but it doesn't has HDMI, it doesn't has this or that. So we decided, let's make something powerful. And this is our most powerful board at the moment. It is with dual core, it has SATA, it has HDMI, runs on 1 gigahertz and has 1 gigabyte of RAM. So it outperforms Pi in every means, but of course it's far away from do-it-yourself in this form and package. And then people start comparing, say, okay, but Raspberry Pi costs $35. This is powerful, this is okay, but it's expensive. And then we decided to make board which can compare with Raspberry Pi in price. This is our latest OLWinner A10 board, which is named Lime. And our godfather is here. On the previous Fosdem, Atanas told me, why don't you have a board with a fruit like Raspberry Pi? Name it Lime. So, this is only €30, board which is again on 1 gigahertz, running on ARM v7 core with 512 megabytes of RAM. It has SATA, which allows you to plug 1 terabyte hard drive to it, so you don't have problems with the external space. It has lithium polymer battery charger, so you don't need UPS. You can make server and to plug it one small lithium polymer battery here and to run hours just on the battery. So if we make one conclusion, what we did from February 2012 when everything started till February this year. We have 14 different OLinuXino boards, starting from 22 euro for the IMX 233 board up to 65 euro for the double core A20 board. They are used in thousands of applications, starting from blinking LEDs via internet and going through industrial automation. Even people use it in automotive. There are hundreds of derived works from our CAD files, people which made their own boards based on our design. And there are 1,000 people who learned that it is not so difficult to make his own computer at home. What's next? This year, OLinuXino is releasing octa-core device with 8 cores, and we have almost ready 4-core device. So this is what we will see this year. And this is where the resources for the project. Everything is on GitHub. When you go on GitHub, you can see the CAD files, how to build the Linux, how to build the Android, and everything you need to build your own computer based on our CAD files. That's my presentation. If you have some question, yes? For the software, let me tell you that we use 4 different processors for the moment. Some of them has no binary blobs. Some of them has binary blobs. Some of them has binary blobs, but there is work in progress from Linux Sensi, which are reverse engineering the video acceleration and Mali 3D accelerator, but they're still not complete. By the way, we are running hackathon in AW building. There you can see a OLinuXino board running Android and Debian, and there you can see also some Arduino boards which we are promoting on Fosdem. On the boards there, the video player is running with hardware acceleration, but for the moment, the only support file formats are MP3 and MP4. So, if you want to play some other format, the video acceleration will not work.
Another question?
For the Lime, you have chosen to expose the GPIOs over a pin spacing, which is not really hobbyist friendly.
Yes,
was it to maximize the number of pins you can expose?
It has about 200 different pins, GPIOs. We either had to expose them all, or to make the board big, and our intention was to make the board as small as possible, because everybody say, yeah, but Raspberry Pi is credit card size. Yeah, there is adapter, or you can make shield and to expose more user-friendly the GPIOs.
Regarding the development of the PCB, can you tell us which CAD software you used and how does this software that you use compare with
Very good question. Very good question. We use Eagle because we use Eagle for 15 years, maybe more. And one of the differences between the free and open source software and open source hardware is that you can develop open source software just with your computer. But to develop open source hardware, you must buy CAD system, which might cost thousands. And I have seen projects which say we are open source hardware, but they are made by Altium or something like this, which costs 6,000 euros something. And I say, how many contributors you will have when your CAD costs 6,000 euro? We made our decision to move to open source CAD program, but it's a very painful process. Because, for instance, we run some projects on KiCad, and it takes about 3 times more for our developers to make the new design on KiCad. But this is the future. This is what we are going to do. Because when you use open source CAD programs, you increase your collaborator and contributor database, actually.
Would you recommend the KiCad to all of us?
We have seen a lot of products, but it seems KiCad is most sophisticated from the open source CAD products for the moment.
Thank you.
Yeah.
Availability of the all-winner parts. Some might be concerned about that.
No, it's not problem. All-winner produce, I think, about 5 million chips per month is selling.
I was thinking long-term availability. How long will they be produced?
Yeah, that's another story. All-winner is selling about 5 million chips. This means that there is a lot of inventory on Chinese distributors. You have no problems for just search on Alibaba or any of these trade sites, and you will see thousands of companies are selling all-winner chips. Long-term availability is another story because, time out. Long-term availability is a problem which all-winner never faced before, because usually the time cycle for the tablets and for the phones system on chip processors is about 6 months. This is their peak sales. After 6 months they start to decline. After 1 year comes double core or 4 core, octa-core. Next year will be 16 cores probably, and all these chips become obsolete in 6 or 12 months. So you cannot expect that somebody will keep selling this for 10 years, because in 10 years they will have no market at all for those chips. There will be 128 cores probably after 10 years. But what all-winner saw with this project is that open source hardware is extending the life of their products. The tablet manufacturer do not use all-winner chips after 6 or 12 months, but a lot of companies made the designs with all-winner chips because they had access to CAD files which are easy to get and to test and prove concept and to put it in the industry. So they see that they can sell more chips in longer term if they support the open source. And what I have like insurance from all-winner is that if they decide to discontinue some of their chips, they will make us notice at least 6 months, so we can stock whatever quantity we want to foresee for the next years.
Thank you for your talk. And if you have another questions for him, you can ask him just out there.